Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 332, Subsequence with the minimum score. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. This one, as you can see, I made two really silly mistakes, which we'll go over later. But I think the concept I actually had very early on, but I wasn't, I don't know, I think... sorry, I'm just also like doing almost a retrospective of how I did during the contest. I think I'm just like a little bit... I don't know. I don't know what's preventing me from kind of going full or out these days. I think maybe I'm just a little bit, I don't know, not the top of my game, to be frank. But that's okay. I don't need to, these are just things. I'm not, my self-worth is not based on these contests or the rating or whatever, so it's fine. But it is what it is. But yeah, so let's go over this problem actually, right? So basically, there is a bit of parsing in this problem as well. The idea behind this thing is kind of look at the score function, right? I mean, maybe also the other thing you want to look at is check out the constraints, right? And the constraint here is going to be 10 to the fifth. The reason why I say this is because if n is maybe say 1,000, maybe even less, I don't know, you could do a dynamic programming problem, right? Because I think there's an n squared solution, dynamic programming. So yeah, but in this particular case, given that n is 10 to the fifth, n squared is going to be too slow. So the thing to analyze, or the way that I analyzed it, was to make an observation about the scoring function, right? The scoring function is very not, or like, it's the thing that for me it stood out. And what I mean by that is that it stood out as in, it definitely looks very funky, right? Or like it's not some. Is that the right way to phrase it? Or it just stood out to me as non-conventional, and maybe it's just different. It took me a long time to say that. It just looks different. So for me, I was thinking about it, right? And this scoring function is really just saying, if you remove, let's actually put it in a little bit here, right? What I'm saying is that, let's say, right, the scoring function is such a way that if you remove just even this one or this k, then you get penalized the same way as if you get subtract everything in between, right? So that's observation one. Once you kind of see that score function, you go, okay, well, in this case, especially when you're talking about subsequence, another thing that, to be honest, let me know in the comments if you have any question about some of the things that I'm explaining, because I think subsequence is a thing that comes up a lot on Leetcode, on interviews, on competitive programming. So there may be some stuff that I hold to be true that I might not explain explicitly, and for that I apologize, because it's hard to kind of, have a video for everybody. But the way that I think about subsequence is that there's a sort of a greedy kind of way of thinking about it, right? Meaning that if ABC, let's say we're deleting everything in the middle here. If A, B, C, G, L, M, N, right? Let's say the subsequence is, or the things that we're trying to match S is this, right? If A, B, C, Y, N, L, M, N is in the subsequence, then if we remove the Y, A, B, C, L, M, N is also in the subsequence. And what I mean by that is that now, in this greedy kind of way, if we can reduce this problem to just subtracting something in the middle, right? And checking that it is still a subsequence. Even though, like, yeah, can Y be part of the subsequence? Yes, but we don't need it because it doesn't penalize us in any way with respect to the scoring function. That's why I put emphasis on the scoring function, is because once we do that, then we can remove this. And then the next thing that I thought about is that, okay, given that the scoring function and that we can just remove everything in the middle, is this, I think during the contest I asked myself whether this problem is binary searchable, given this. At this point I do not know whether there's a function that makes it cheap enough to do binary search, but I'm just asking myself of, okay, let's say we could arbitrarily remove X number of characters from the middle. Can we binary search on that? Even if it's really expensive, and in a naive way, you can't do it, right? And we'll get to that in a second, is that, and the short answer is yes, you can binary search on this because, on this function, because let's say you have some f of x, where x is the number of characters you can remove from the middle in T, right? Is this function binary searchable? And the answer is yes, because if you remove 6 characters, right, it also means that, or if you remove 6 characters and sorry, give me a second. If you remove 6 characters and you still can get S from a subsequence, then 7 is going to be true, right? Then what I mean by that is that if you remove 6 characters, you can remove 7 characters and it will still be true. You can remove 8 characters and it'll be true. You can remove 9 characters and it'll be true, right? So this looks like this, where the T stands for true. Conversely, let's say you cannot remove 5 characters. You try removing 5 characters, you have this magic function, you remove 5 characters, and then you cannot make a subsequence, right? Well, what does that mean? That means that if you remove 4 characters, it's still no good. Remove 3, it cannot be good, because that's just how it, because you're removing fewer characters. So that means that you have a f of x will look like this, right? In some way. And from this, you can figure out that it is binary searchable. I think people ask this sometimes about how do I think because this was on a daily problem recently, or maybe last week's contest, I don't remember. But a question I get is, how do you know that you can, or like what makes this problem, or what gives me the impression that this problem can be binary searchable, right? And to be honest, I don't know. Like, I don't look at a problem and I go, okay, this is binary searchable. I mean, okay, with enough experience, some problems and some patterns do come up, so maybe you have some intuition. But for me, the idea is more about, okay, for me, at least at my level, maybe, there are people who are smarter than I am, etc. For me, I go, okay, let's assume that we can binary search. How would that look like, right? What would that look like if we can binary search? And then for this one, for example, that I come up with, okay, let's say we come up with this thing. This is how I get, okay, if I have f of x, which is this function, and what would that look like? Is that function binary searchable? And then now I have this function, I go, okay, oh, it is binary searchable, right? And then now I go, okay, can we add, what would be the complexity of this function? And there are a couple of ways to do it. Let's say we do it naively, right? The naive function is, of course, let's say we have these 2 functions here. The naive way of doing is just, okay, so given some L is equal to 5, you first, by deleting the first 5 characters, see if this is a subsequence of this, right? And then, okay, the answer is no. Okay, let's try deleting the second 5, delete the third 5, delete the 5th 5, right? And or whatever, right? I think I skipped 4, 5th. In any case, you get the point, right? So basically now you're trying every possibility, right? Well, in that case, what's the complexity? Well, you could calculate the subsequence math or whatever in linear time, and of course there's going to be roughly speaking O of n of these pieces that you can remove. So in a naive way, this function is going to be n squared, right? Oops. Of course, that's no Gucci, because we binary search on the length of the substring to remove. Of course, that means that if the length is length m, this is, and maybe I was lazy on the n squared. Maybe it's actually n times m, but for the subsequent stuff, because it's, let's see, it's O plus m, right? And then there are M sequences, right? So that's actually more specific if you want to, maybe it's a little bit something like that. And then this is this times log of M, where, just to be clear, n is equal to length of s, m is equal to length of t, right? Because you're binary searching on the length of m that we can remove from the middle, and then you get this monster, right? Regardless of like m plus m or not, this is still too slow, right? Because we have 10 to the 5th times 10 to the 5th times log n, too big. You could do the math on what that equals to. TLDR, too big, right? Yeah. Cool. Yeah. So then the idea is how can we figure out how to do this in faster time? So the idea that I came up with relatively quickly, but I don't know, I think I'm just a little bit out of shape with these practice. I think that's why some people got it very quickly, and I got 2 wrong answers based on this part of the implementation, to be frank. But the idea is just caching the prefix and the suffix, right? The idea here is saying, using this example again, let's say we want to remove these middle 5, right? Then maybe this isn't a good example because it doesn't really come up that much, but let's just say there's more letters, right? But basically now we go, okay, the first 4 letters, in a greedy way, how much of the prefix does this use, right? So now this number is 4, and then what we do is that we also calculate the suffix. How many letters does this use? So then this actually use this many, which is, I don't know, 8, right? I mean, you could do some math on the index and the 8 and stuff like that, but then now this allows us to calculate a sliding window in all of one time, because then now the next calculations that we do is just the y, which is 5 actually, and then the 8 is k is actually 4, right? And then dot dot dot, right? So then now you're sliding, and then the check here is just to see whether there's any overlap. And what I mean by that is that this is not possible if you have so few letters. Let's just say I don't know. I don't know, right? But basically, if the left side, the prefix requires this much, and then the suffix requires this much, then it's not possible, right? Because you have to delete stuff, and then you have to use the same character more than once, right? To make it a subsequence. So then that's no good. So that's basically the idea. Otherwise, if there are no overlaps, then you know that this is good, because now in a greedy way, the left side we use the greedy things, the right side we do the greedy things, and it makes a subsequence. That's basically the core idea. There are some edge cases in how you handle it, or at least in how I wrote it. So that was very sloppy for my part. But yeah, let's go over the code. Sorry, catching my breath for a second. That was a lot of talking. And you know. Sorry, let me drink some water real quick. But yeah, so basically what I do here, first of all, is just calculate the... so I basically use this function to calculate this thing of the given... So this is given, or at least prefix sub I is the amount of prefix of s used to match the first I characters of t. Something like this. I mean, it could be off by 1 because it should be I plus 1 or something like this. But that's basically the idea. And I wrote this function. You can kind of check on it, at the time. But it's just sliding. It's basically sliding window, or not sliding window, but just like. And this is a very. I think this is a Leetcode Yeezy. So definitely So I'm not going to go over it that much. If you're here, you should really practice this part even if you don't get it. But basically, instead of matching and return true or false, we just store for each index the how many, like I said, how many prefix of s that we use. And I made this in a function so that I can reverse it a lot of times, so that I don't have to type it twice, or worry about off by ones, or only worry about off by ones in one place, and so forth. And then once I have this, and of course I have to reindex it to get the n. And I'm going to go over the binary search part first. We're binary searching from 0 to m, which is the length of the t, and then removing stuff from the middle from that. So this is the function we have, right? So basically we ask ourselves, let's say the middle is a t. What does that mean, right? That means that the right answer is on the left side, inclusive, right? If the answer is, or the current answer is an f, that means the answer is on the right side, exclusive, and that's basically how I do it. And of course I use inclusive bounds. It just makes more sense to me in general. You may have a different way of writing it, but if left is equal to right, then you have one element, and that's the answer. I did this by accident. Anyway, the meat of this problem, of course, or at least the second meat, after you already got the prefix and suffix and pre-calculation, is just this good part. So I have a couple of mistakes here. I just had an off by one on some of this before, but I didn't handle this case very well, which is that we're just removing the suffix. Basically, this is saying that let's go with this part first, right? Meaning that if prefix sub I is less than n, this means that there's a valid way to do the prefix. There's a valid way to do the prefix, and if I plus target is greater than or equal to m, that means that we went off the board, and this is just effectively mean that we chop off everything after I, right? So that's why I returned true. I didn't have this, and that it gave a wrong answer as a result. The second place that I have a typo was that I actually used n's for some reason. It was very silly. Two wrong answers, two silliness. But for this part, this is just saying that we did not go over the board. So we basically took a chunk in the middle, and basically this part is just saying that the index on the left side of the usage is the same as is less than the index that we get when we chop from the suffix. So return true, because now this is possible. And this is basically a way of doing sliding window with these pre-calculation. Otherwise, return false, meaning that there's no possibility, and this is binary search, and that's pretty much it. We already went over, I lied, we did not go over complexity, but if f of x is equal to, this is wrong, whoops, this is f of x, but that means that the total time is equal to O of f of x times log m, and space is equal to O of, I think just O of m, you could say that I did some weirdness here to make it whatever, but I'm going to say it's O of m. And of course, in this case, if f of x is equal to O of n, then this is n log m. Plus n. I think this is actually O of m, because I think that's why I got confused during the contest, because usually you search through the other one, but because we prefixed this in a different way, this is actually an m. So this is actually m log m, because this is O of m the way that I did it. But you could also have done it, n log m is the same. But it's m log m plus n, because plus m part is the pre-calculation, because this part takes O of n because of the j iteration. So let me rewrite this real quick here so that it's less confusing. But let me also make this smaller so you could see all the code. I think this is all the code. That's all I have for this one. So let me know what you think. Let me know how you solve this problem, and you can watch me solve it live in the contest. Now, the time so I'll be sad, but it should be okay otherwise. Okay. S and T, any characters from T. The score string is 0 with no characters from T. Otherwise, left with a minimum index of all remove characters and right, and then okay. Minimums for to make tier possible. Okay, how are people doing so far? Have people already solved this? Seems like I'm in okay company so far. Well, good job, Remix. I gotta stop giving shout out during the contest. But okay, at least not when I'm not done. Okay, so we remove Z, then it's just one length. Okay, and then BAA. And it's pretty big. It's still DP. Hmm. 14 actually, that's not bad. Considering I spent time like double checking it. But BAA T or subsequence. So first of all, we have to remove stuff. Can I binary search? I don't know that I can do sliding window like that though. If I could, that would be easy, but if we remove all of them, it works. I mean, it's binary search above. Can I do binary? Can I do the proof in linear time? Or can I do it in a greedy way? Because they're n of those substrings, so you can't really do that, at least not that naively. Well, actually, can you? Because basically you're basically keeping the prefix and the suffix, right? Because basically when you remove this binary search thing, it's everything inside, because there's no point of keeping anything. But you still have like a moving thing. Can you do the prefix and the suffix in a good way? I mean, I think I have an idea, but one person got it already. Wow, I'm really impressed, to be honest. Can I do it that way? Maybe prefix? So B minimum I think I have an idea. So basically, and then set, and prefix, suffix, binary search. I mean, that's not that bad, but I'm so, 3 minutes is quite a time for solving though. Is it really that? I mean, that's not a 3-minute solution though. Okay. Something like this. Yeah. Maybe that even works, so just give me n, right? So something like this. And then, yeah. Something like that. Okay, so it's 1777. Okay, and then this is like A is that right? No. Oh, it is 6 and then 6. Oh, it has to be. Okay, so it has to increment by 1. If j is less than n, say. Okay, so 6 and then 4. Okay. What can I do now, right? Okay, I mean, this makes it binary searchable, I think, but I don't know. I think so. So then now we want M is definitely reliable. Okay. If this is good, then we will remove more fewer letters. So I think this is right. Then we move this. Okay, fine. And then the def good target. How do I do this? Okay, I got it. Yeah, okay. How do I say this in a good way? I need the visualization, that's why. Okay, so then if this and then Okay, I think I got it. Yeah, maybe. Suffix is on M. Yeah. Oops. That's not quite right. Well, I mean it's. I think it's just N minus. Okay, that's not right either. What am I doing? So this is the number of letters you remove. So 3. That should be the answer, really. Maybe. Because we remove 3. Because that's, in theory, the number of things you remove. Right, so this is 3 because 2 is good. One is this, but this plus, oh, B is not right. This is not right, is it? This is, oh no, this is B, and then Z is no good, but then B plus, we remove 3. Why is target true? If this is true, then we try something, we remove more things. That's not true, is it? Maybe that's why I'm doing it weird. Two and 3, okay. Still not true, but, well, not correct, but it may be a little bit better. Target is equal to 2, then print I target. So 0 and 2. So 0 and 4. So 0 and 2. So that is actually only -1. So this is this -1. Because, okay, fine. 3 and 3. That's also not right, but okay, fine. Zero and 3. 0 and 3. That's true, but 0 and 2 is good too. Right? Basically, you want the answer to be 1. Did I mess up this? I plus target plus 1. Whoops. Keep that there for now. Okay. Is that right though? Alright, let's at least debug the answer real quick. 0 and 1. So you have 0 and then you have length 1, so it goes to the one next to it. Okay, fine. I don't know if this is right, but I'm gonna submit it, YOLO it. Oh no. Oh well. People have gotten this one though, so I'm only 4 people, so maybe I'm wrong. Oh, and that a lot of people got this one. So this is 2 but expected 0. Add because ED is in it. Do I have 0 in my thing? Maybe not. If this is good, then we make it smaller. That's right. Okay. This is 2 and 3. Oh, this is just really awkward, isn't it? Because... But why? Tell me why. I mean, I think I could hack this, but I want to make sure that I get this right. Because I don't get why. Okay, 1 is force. So then left is equal to mid plus 1. So this is just really bad. So if this is force, meaning that 2 is not enough. No, 2 has to be enough. Oh, 1 is not enough. That's also not true. Because here, it thinks that 1 is not enough. Why does it think 1 is not enough? Because, so 0 plus 1, so then now this is 2, and then that goes out of bounds. I think the idea is right, but I'm doing something stupid. I mean, removing both of them will work, but the way that I'm representing this is not right. I don't want to hack and get another 5 minutes penalty, but this is just a stupid way to fail. So removing 0, I don't think that, so mid is 1. This should be true though. If we remove 1, then is this right? 2, 3, and 0, that's it. Wait. So this may be wrong. Why? Because 2 is true. Because 0 and 2, that's good. Right? But 1 is force. Why is 1 force? 1 is going from 1 to... I think my indexes are wrong. Because I'm not counting the null character. Okay. Is this good enough? I don't know. Let's give it a YOLO. Ah, man. Also, I left the print statement in, so it would have been sad anyway. So the answer is 2. True, what is true means? True means that it is possible. So 3 is possible, but 2 is not. Why is 2 not possible? Let's see. Is it because of this weird -1? And this is a... I don't know how to handle this one, that's why, maybe. 2 is force. No, that should be... because you can remove B and Y, I think. At the end, that's why. So Y, D, E, C, A. So then now this is 19. And then this should be 19 as well. Okay, fine. Oh, I see. Whoops. I thought I handled it, that's why. Okay, well, does that give me the right answer now? Nope, still no. Almost submitted. Okay. So 3 is true, that's fine. 2 is not true. Because this 19, oh no, this 17 should be handle it. Right? I think, I think if I press target is greater than equal to m and prefix of I is not equal to n, is less than n, then we should return true. I think I missed that case where it goes off the board and I try to hack it by this should be m anyway, right? N doesn't really make sense. I don't know why. That's just a bad mistake as well, actually. But somehow didn't get caught. 1302. Okay, YOLO again after 2 wrong answers. Okay, I mean the idea was right, but I just didn't know how to handle edge cases very well. It was very fast after the Q3, it seems like. But Q4 really destroyed me. But I had that one right. It's just let's see, right? Well, like I didn't have that one right, obviously, but I had the idea. So it's just that I didn't handle the edge cases very clearly. So in theory, if I took 7 minutes off that, that's 24. That's a very respectable time. 24 minutes would have been top 10. But I definitely clearly had. I mean, I definitely had issues. I didn't really think this case through. And I actually kept this somehow too. Well, I kept print statements in both of these. That's pretty bad. But yeah, I didn't really think this case through enough, to be honest. With respect to what if it goes over. If it goes over, then that's fine. And also, this is n makes it a little bit awkward because I don't know how this didn't run out even earlier. Because I could easily be. I guess at some point you just kind of we got lucky on the test cases, because that's a bad thing. Because I was clearly supposed to remove things from the M. Oh, hopefully the test cases are strong on this one. They cover binary search, which is at least for me very easy to make a mistake about. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, the explanation, this contest maybe, and everything in between. That's all I have, so stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.